Hello, 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 hello. Listening. Good afternoon, everyone. Welcome back to the Faculty Development Program. Now I would like to welcome Dr. Ajay Kumar Singh, Professor, Department of Computer Science Engineering. He have more than 25 years of experience. He have published more than 75 research papers in the reputed conference and journals, as well as 5 international patents has been granted on his name. With this, I want to hand over the session to Dr. Ajay Kumar Singh.
No, sir. No, sir, you're not.
Am I audible?
Yes, sir.
Okay, thank you, Preeti, for giving introduction. So, today's session we are going to go for this machine learning, and that too related to your supervised learning. So I'm going to take unsupervised learning on some different thing, that is tomorrow itself. So today we are going to see something about your supervised learning, and we are going to see some of the algorithm. Practically, we are going to implement some algorithm by using your Python also, like linear regression or logistic regression. And we will be doing some hands-on, practical of this supervised learning by using Excel sheet also. Right. So without wasting much of our time, we are going to start this session. So I think my screen is, let me share my screen. Host disabled participant screen. This is saying something is unable to share this.
Ajay sir, you can share now.
I want to share the screen. So
yeah, share it.
Yeah.
It's enabled.
Yeah, got the goodness. Okay, sir. So I think my screen is visible.
Yes, sir. Yeah, yes, sir.
Fine. Okay, so let's start. So let's start from the very basic. That is all about your learning process and all that. And then we will be taking some hands-on experience. That is practical example of the supervised learning. So almost all of you know something about this supervised learning, unsupervised learning. So how many of you know supervised learning? Can you unmute? Unmute. You cannot do that. Sir. Okay. No issue. Okay, some chat boxes. So I think little bit I know. So somebody has written, I know something about this supervised learning, unsupervised learning. Right. So basically, this machine learning is divided into 4 different aspects. So let me show the slide itself. So this learning is basically divided into 4 different groups. One is your supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Okay. So today we are going to focus more on this supervised learning. And my next session, that is tomorrow, I'm going to focus on this unsupervised learning. So supervised learning, we are going to have label along with some input is already there. At the same time, some output is there. Say as for example, suppose I want to see whether the given image is of cat or given image is of rat. So ultimately, this cat and rat, these 2 things are nothing but some sort of your output. So I'm going to relate input with output, isn't it? So let me show that slide. So in machine learning, basically.
So Ajay sir, sorry for the interruption.
Yes.
Yeah. I wanted to tell you, full screen mode. Yeah, slideshow.
Fine. Okay. Fine. So this is very important that in this traditional way of doing programming is that we are going to give some that some program is written, and based on that program, it is going to ask some value of the variables, and based on the value of the variable, it is going to generate the output. Like suppose we are generating factorial of any number. So it is asking for what number you want to generate factorial, and accordingly the computer is going to give the output. But in case of your machine learning, so data is given at the same time this output is also given. Say, as for example, I'm going to give the image of cat, I'm going to give the image of a rat. Cat and rats are there. So in that case, these are cat and rat are acting as one of the input. And what is the output? That output is your cat or a rat. Fine. So either the image is going to be your cat or image is going to be your rat. So in machine learning, we are giving output also. So this is different from your traditional way of doing the work. So traditional way is this one. In machine learning, we are giving input as well as output. And then we are going to go for some programming. Okay. So these are the basic of this one. So we will be taking some of the algorithm. So I think this part is very clear, that supervised learning. So supervised learning, it is saying that I'm going to have some label, and based on that label, I'm going to segregate the data, I'm going to classify the data. So if the moment you are going to get the word that classification or regression, so we are going to say it is some sort of supervised learning. And in case of your unsupervised learning, we are going to have some sort of your keyword like your clustering and all that. So if I'm going to make some cluster in which exact data is not defined, exact label is not given for the given output, so in that case, we are going to say it is unsupervised learning, which will be taken care later on in tomorrow's session. Okay. So very simple example is given over here that is all about your learning. So this cat is there. So some experiments were carried out. So cat is there, and this fish is lying somewhere here. That is food of the cat is there. And the cat is locked for 24 hours. So cat doesn't know how to come out from this particular case. And it is fitted with pulley, lever and all that. But a time came when cat started, moving from, from one wall to another wall and so on. So in order to come outside of this particular case. So by mistake, this cat clicked this particular pulley. The moment this cat clicked the pulley, so this door opened and cat went outside and took fish, and she went inside the cage again. So in this way, a number of times this has been carried out. So after 24 hours, sometime it took, suppose, more than this 24 hours, sometime it is before this one. So ultimately, cat came to know that if I'm going to click or hit this one, so ultimately this will be opened and I'm going to take the food and I'm going to come back. So in this way, this experiment were carried out in order to have this in the sort of. Now, coming back to some of the algorithm, so not going in much detail of this one, so you might be knowing of this supervised learning. Suppose some data are there, labeled data are there. Based on this, and we are going to create some model. This model can be created by a number of different algorithms, like suppose your descent gradient is there, your k nearest neighbor is there, your random forest is there. So a number of different algorithms are there, SVM is there. So by using that, we can create the model. And then after creation of this model, we are going to predict the test data. So basically, this entire data is going to be divided into two parts, one test data and another is your training data. So training data, mostly we are going to have 70 to 80% of training data, and rest 20 to 30% we are going to have that test data. So we want to test whether our model is giving accurate data or not. So what is the accuracy of my model? Maybe 90%, 98%, 92%, whatever may be the accuracy. So we want to test that also. So this is all about your supervised learning. That is labeled data is given. That is, this square is given, this triangle is given. The label is given, so this label is given with this particular feature, like the square and triangle. Now, coming back to this KNN, so I'm going to minimize this slide. So this is one of the simplest algorithm of machine learning. So this is one of the very simplest algorithm of machine learning. So let's see why it is simplest. It is called simplest algorithm. So here, suppose in y-axis, suppose I'm going to take height. In x-axis, suppose I'm going to take weight. Just okay. So weight of this. And so cat and dog, two different, the categories are given, classes are given. So one class is of cat and another is class of dog. And this is the data which I want to check, whether this data belongs to cat or this image belongs to dog. Isn't it? So this is my test data. So in KNN, K nearest neighbor, what we are going to do? We are going to take K points, which is nearest to this particular test data. So like in this case, this circle shows that the value of K is 7. Isn't it? The value of K is 7. So here we are able to see that this circle is nothing. It is saying that K nearest means K nearest point to that test data. So how many value of this K is there? So we are considering the value of K as 3 in this case, in this circle. So now in this case, we are going to see the majority of that particular image. So the majority of this image is cat. So in that case, we are going to say if this particular data belongs to cat. So this image that we have given for testing, so this test data is nothing but this image is of your cat. Because we assume that cat is, the majority of cat is there. So we are going to take cat as your output for this particular test data. So up to here it is fine. Any doubt is there? Okay. Assuming you're getting. Now coming back to your, when I'm going to increase the value of K, like in this case, I'm going to increase the value of K as 7, isn't it? In that case, how many cats are there and how many dogs are there? So you are able to see earlier, this image was taken care as your cat. Why? Because majority of cat was there. But the moment I increase the domain of this particular nearest neighbor of this particular test data, now I'm going to count the number of cats. So how many cats are there? So here basically we are having 3 cats, isn't it? And how many dogs are there in this circle? That is 4. So why I took 4 and 3? Because I'm going to encircle the nearest points. I'm going to put one radius that is near to this one. So I'm interested to take only 7 data, 7 points, 7 images. So out of the 7 images, 3 cats are there and 4 dogs are there. So this is the value of K. K means 7 data I'm supposed to select. So 3 of them are cat and 4 of them are dog. So in this case, this data point that this image belongs to dog. Is it okay? Earlier, it belongs to cat because the majority of this cat was there when we took the value of K as 3. K means the number of data, the number of image in this case. So 3 image we took, that is 1, 2, 3. And since majority belongs to cat, so this image test data that we want to test this image. So this test image it is saying that this is cat. But the moment I increase the value of K to 7, so now 7 data are there. 1, 2, 3, 4, 5, 6, 7. In this particular circle, 7 data are there. In that case, we are able to see that this particular image has changed from cat to dog. Now it is saying the majority belongs to dog. So in this case, this gives some sort of ambiguous output. Because the same data, once it is saying it is cat, the same data, in another case it is saying dog. So if I'm going to increase the value of K, so next time it may be more than that. It may be, sometimes it may be cat, it may be considered as cat because the majority of cat will be there. Sometimes it is going to say that this particular test data is of dog because majority of dog is there. And here basically we are taking the value of K as odd number. We are not taking even number. So why we are not taking even number? Can anyone in chat box you can write? So why we are taking this K as your odd number? Why we are not taking even number? Any idea? Okay. No idea. So because I don't want to have tie. Yeah, very well. So we don't have tie. Isn't it? That means 2 cats are there. Now assuming 2 dogs are going to be there. So in that case, I'm unable to identify this data point belongs to cat or this data point belongs to dog. That's why it is preferable that every time you choose the value of k as an odd number. Fine. So here we are not taking this value as an even number. So one more condition is there. Suppose the number of category is, suppose number of classes is n, so it should not be multiple of this n. Like suppose 2 classes are there, and you are taking, you are taking the data that is value of k as your 2 into suppose 3. 2 is the total number of class, that is cat and dog. One cat is there and another is dog. So 2 classes are there. So 2 multiplied by 3. So how much? 6. So in that 6 also we cannot identify accurately. Why? The possibilities are there. 3 of them is going to be the cat and 3 of them are going to be dog. In that case also it is going to have type. So 2 important conditions are there, that k has to be odd number. At the same time, the value of k cannot be the multiple of the number of classes. So if it is 3 class, so it cannot be 3 multiple of n. Right? So in order to avoid this ambiguity. Okay. Now let's take practical implementation of this KNN, so that we can have some deeper insight of this. So I'm going to use this Excel sheet in order to go for this. So even not many categorical data are also present on the net itself, like your iris data is there, sepal length, petal length. So in that case, this data will be given to you. So this data will be given to you. Based on this data, you are supposed to find that this sepal length is given as 5.2, sepal width is given as 3.1. So what is the name of this species? So 3 different flowers are there, like virginica is there, setosa is there, versicolor is there. So out of these 3 categories, so if the length is, sepal length is this one, sepal width is this one, so what is the species out of these 3 different flowers? So by using KNN, we can solve this problem. And for solving this problem, we are supposed to find the distance. So how we are going to go for whether this is nearest to this, because 3 nearest point we want to calculate. The nearest point we are going to have this by using your distance. So many types of distance are there, like Minkowski distance is there, Manhattan distance is there, and Euclidean distance is there. So by using any of the distance, you can calculate the distance of this test data along with the different data that is already present. So I want to have the distance of this test data with all the points, so that I'm going to calculate the nearest point, 3 nearest point or 7 nearest point, and with this particular test data. So this is how we are calculating. So in Minkowski, basically, so just suppose, so this is the formula for this Minkowski. Suppose I is equal to 1 to n. And here, basically it is your xi minus yi. P. So where P is in power 1 by. So this is basically Minkowski distances. Clear? So this is x. We can do r. This is x. This is fine. Now, sometimes in interview they are asking what is when this Minkowski becomes your Manhattan, or when this Minkowski becomes your Euclidean distance. So Manhattan, it is saying that this is nothing but modulus of your x1 or xi minus x0. So we are going to take the modulus of this, mod of this, plus yi. In that case, we are able to see, if I'm going to put the value of t as 1, this becomes your Manhattan distance. So this is your Manhattan distance. And if the value of t is 2, so here the value of t is equal to 1 for Manhattan, and for value of t, or equivalent distance, it will be 2. We already know that simple distance is there. That is your x2 minus x1. The distance of 2 points in any coordinate geometry where x1, x2 are the points. So this is x1, this is x2 whole square. By using Pythagoras theorem, isn't it? We can calculate this. y2 minus y1 whole square. So this is equivalent distance. The simple distance between 2 points x1 and x2 equivalent distance. So in that case, in Minkowski, if I am going to put the value of p as 2, it becomes your this equivalent distance. And you are able to see this 1 by 2 is nothing but root over this. So this is root over this 1 by 2. And this is p is square when p is equal to 2. So this is square of this. So by using this particular formula, we are able to solve the problem. So let's directly go for this implementation of some sort of this distance. So let me come out of this PPT. So let me open one Excel sheet here. Let's start from the beginning. Now here I'm going to take the value of x and y. Okay. So x and y I'm going to take into value. And randomly I'm going to generate some number, isn't it? So it is random. That is random number between some points. Say 1 to 20, any point I want to generate over here. Now, randomly it is going to generate some points so that people are tight. It is going to otherwise all over time. In the same way, I'm going to generate some number. So this is x and y. So this is fine. So 2 points are there. Randomly I generated a number. So I'm going to copy this. So let me copy from here. So I'm going to paste spatial because every now and then it goes on changing. So that's why I want to fix this data. So for that, what I'm going to do, I'm going to go for paste spatial. So I want to delete this. Okay, so I generated 2 points, x and y. I generated 2, that is coordinate and abscissa. And now we are going to see what we're going to do. So ultimately, I got this point. What are these points? In the slide itself, we have seen, that these are the coordinates. So this is x, and this is x, and this is y. So ordinate and abscissa we have taken. Like this point, we are going to talk about this point. So this is your x, that is 95, weight is 95, and height is your 2, between 2.5 to 2. So this is coordinate. This coordinate I have plotted somewhere here. So this is x and y coordinate. And now I want to find some point is going to be there. So let's have some graph of this particular data. I'm going to see some graph. Let's say scatter graph is there so that we can identify what are the different points. So suppose these are the points, isn't it? So based on this point, we are supposed to find, suppose whether this is in class A or this is in class B. So now I assume that this is your class A. So this particular chunk of data is class A and these data are in class B. Is that okay? So now I assume if it is 11 and onwards, so it is in class that is C2, the class 2. If it is below 10, this X is below 10, I'm going to consider this in your class 1. So I think it is fine. Okay. So now I'm going to put the classes like, so if the value of this particular data is below 10, so it is C1. So I'm going to check only X. So it is below 10. So in that case, what I'm going to do, we are going to put C1. That is class 1. Let me copy and paste. So save type and C1. So 4 is here. I'm going to check this number. So it is in C1, suppose. And then again in C1. If it is less than 10, it is in C1. Less than 10, suppose. Let's say 10 is also there in C1. So check it out. If I committed mistake, let me know. So I think it is fine. So less than the value of X less than 10, it is in class C. I assume that this is one of the particular class. This is another class because at randomly we took the data. So we assume that this is the case. Okay. Now, rest is your class 2. So rest is your class 2. So I'm going to C. Rest in class. That is C2. Now we got the classes. So two classes are there. Assuming for the timing, there may be a number of classes. For the timing, assume that only 2 categories are there. That is class 1 and class 2. So before 10, I'm going to assume that this is your class C1, class 1. And after 10, I'm going to consider this is your class 2. Okay. Now I want to test some data. I'm going to put some point here, 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 whatever it may be. And based on this K nearest neighbor, I'm going to identify whether it is falling in class 1, like cat or dog, isn't it? Whether it is falling in this cat class or it is falling in the dog class. So this is what we are supposed to identify. So let's take some of the test data. So assuming, let's say some test data. I want to put somewhere here. Let's go for this one. So that is somewhere 13. X is 13 and Y is 10. Somewhere here I want to put 13 and 10. So our test data will be 13 and 10. 13 and 10. So this is test. We are testing. So we are interested to test the data. Yes, now what I'm going to do, I'm going to calculate all the points from here to this place, from here to this place. This test data, along with all the points, are going to be calculated. All the distance are going to be calculated, so that I'm going to find the K number of nearest point to that particular test data. So I'm going to put formula. So what is the formula here? We are going to write. So formula. So I'm going to calculate distance. Let's say it is your distance. Right? So I'm going to do this. So here we are going to calculate it. So what is the formula? Suppose we are going to go for Euclidean distance for the timing. It may be any distance. So for the timing, we are going to take Euclidean distance. So what is that? SQRT is square root of SQ. RT is square root of test data minus this point, isn't it? That is test data minus first point, second point, and so on and so forth. Now, is it okay? Then multiplied by square root. Same process, because it is square. Means 2 times we have to take the same point. So 2 times we have to write this minus that also. Fine. Multiplied by 2. Fine. Why we did this? Because of the Euclidean distance. That is root over x2 minus x1 and whole square. Whole square means 2 times I'm going to multiply the same one. Plus y2 minus y1. So this is y, isn't it? So plus y2 minus 1. Fine. And this is multiplied once again. Why we are going to multiply once again because it is your square. So this minus this. Okay. So I think this part is clear. So I got some distance. So suppose I got some distance. And now I'm going to drag this distance because I want to calculate all the points, isn't it? So I want to calculate all the points. Means this test data with this point, what is the distance? With this test data, what is the distance? With this test data, what is the distance of next point? And so on and so forth. So I do this one. Now suppose if I'm going to click this one. So it is showing that this point, it is not taking the difference of this and this. So it is not going to give the correct output, isn't it? Now suppose say, as for example, if I'm going to click this, so it must take this point and this point. But it is taking the other cell. Why it is taking other cell? Because we dragged this one. So it is going to take the relative address. So we have to make this as a absolute address. So for absolute address, we have to press F4. We have to put $sign because this is fixed. And we are not supposed to change this next cell, next cell, next cell. So this is fixed, but these values are changing. These values are changing. That's why we are doing this F4 for making it as your static fixed form. So now it is your absolute data, not relative. Okay. So let's again enter. Now let's again try to drag. So value has changed. Now let's see. Let's take any at random. Now it is working. This point with this one. Let's take this one. This point with this one. Let's take this one. So let's take this one. So this point and this one in this one. Okay. So we calculated the distance. Now what is the next step? That the nearest point. I want the nearest point. So for that, I am going to arrange this particular data in increasing or decreasing order. So suppose I am going to arrange this data in increasing order. So let's make some filter over here. I'm going to go for filter. So applied one filter. Filter, you are able to see that filters are there, isn't it? So I'm going to go for sort smallest to largest, isn't it? So at the same time, let's cover this point also, so that this is going to be respected. Add data to be sorted. Then we are going to go for the smallest to largest. At the same time, so let's see whether this particular data has been changed or not. So this is also required. Otherwise, it is not going to give the correct output. So what we are going to do, we are going to take random somewhere, some value, and let's copy over here in order to cross check whether it is changing these values are also or not, or it is just changing the 3 different columns. It has to change all the columns accordingly. So filter we have already added, I think. Now coming back to by this data, basically you want to sort out. I want to get all this data, all this data, smallest to largest. So I think another values has changed. So let's check 1610 3 is 2, 1610 3 is 2, 1610 3 is 2. So I think the value has, with respect to this particular data, it has changed all the data. So assuming this is correct. Okay. Now, the next step is that, so we are supposed to put some sort of a ranking here. So I'm going to put the rank over here, suppose. Rank. That is 1, 2, 3, 4, and so on. Because I want to take the value of k. Sometimes, suppose 3, sometimes 7, sometimes based on this rank, we are going to take the value. So if it is 1, we have to convert into 1, 2, 3, 4. Isn't it? So 1, 2, 3, 4. So this is the rank. So we created a rank according to the nearest data. So let's look for this. Now, here suppose, now I'm supposed to take the value of k one by one, isn't it? Now, suppose here we are saying the value of k is 1. What is the output? K is equal to 2. Now, what will be the output? K is equal to, sorry, so this is odd number, isn't it? 7. So why it is odd number? So that to avoid this I. So that's why we are doing this. 9, so on and so forth. So assuming 3 different values for 4 different values for k. So when the value of k is 1, so what is the nearest point of this 1310? That is 1310 is lying somewhere here. 1310 somewhere lying here, isn't it? So this point is lying in this class, that is C1, or it is lying in C2 class. Now we are segregating that. So let's delete this output one. So just check. Now, when the value of k is 1, so when the value of k is 1, means it is falling in which category? When the value, the nearest point is 2 point something. So this is the nearest point, isn't it? So for the time being, both are having the same nearest point, that is C2, C2. So in that case, it is falling under which category? C2. So here we are going to write C. So you may write the value of C1 equal to, or enter the value of C2 equal to. Fine. So based on this C1, C2, we are going to decide what is the final output, isn't it? How many C1 and how many C2? If k is equal to 1, so if k is equal to 1, only one C2 is there. So only one C2 is there and no C1. What will be the output? If k is equal to 1, the category of that test point 1310 belongs to C2, isn't it? Because the majority of C2 is there. So the answer is C2. When k is equal to 1, the test data, that is 1310, belongs to second class. In the same way, we are going to go for this C. So this is your k nearest neighbor. So next attempt, we are going to go for k3. So 3 nearest point to that test data. So this is 3 nearest point, 1, 2, 3, isn't it? 1, 2, 3. So here also we are able to see, it is going to, unanimously, it is going to take this C2. It is not going to take C1, not a single C1 is there. So we are going to say that it is falling under C2 category, class 2. Yeah? So how many C2s are there? 3 C2s are there. And no C1. You don't see that. In the same way, if k is equal to 7, so we are going to take 7 data points. 7 data points. 1, 2, 3, 4, 5, 7. 7 nearest point, isn't it? From this particular test data 1310, isn't it? And then we are going to see how many C1s are there. Only 2 C1. Only 2 C1 is there, and rest 5 are C2. Isn't it? 2 C1, 2 C1, and rest 5 are C2. So in which class? Majority is C2. So the final output will be C2. What about this one? When the value of k is 3, so majority is of your is C2. So answer will be C. Fine. I think you are getting. Any doubt is there? Okay. Fine. So what about 9? When the value of 9 nearest point is taken, 9 nearest point is this one. So how many C1, how many C2s are there? So let's count. So 1, 2, C2, suppose 1, 2, 3, 4, 5, 6. 6 C2 and rest C1, isn't it? 6 C2. So 6 C2, 6 C2, and out of 9, so 3 are left for C1. So obviously, in this case also, C2 is the correct answer. So in this case, now we are able to see that this point, that is 1310, is the nearest to that point. Yeah, so 1310 that belongs to C2. So 1310 for all this point, that is all about your A1, 3, 7, 9. So 9 points are having the majority for this C2 class. Fine. C2 means this is your C1 and this is your C2. Yeah. Now I'm going to take some points somewhere inside this C1. Like suppose I'm going to take, suppose here, let's say 9, and then we are going to take 12, 9 and 12, isn't it? So here I'm going to change this as well 9. So you may copy and paste somewhere, so that otherwise it is going to change that around, isn't it? So you may copy somewhere, Control C, and paste this as a paste spacer by value. Yeah, for future reference, isn't it? You can do that. Because I'm going to change this point. So now my point will be 9. The moment I'm going to change this 9, so you are able to see that distance is going to change. You are able to see that distance has changed. Now here, so this is your X, and I'm going to talk about Y, that is supposed to 12, 9 and 12, isn't it? So I'm going to go for 9 and 12. So let's say this as your problem. The moment I'm going to change this as 12, click somewhere here. So this point again, it will change. So this is changed. Yeah. Now again, I have to make the ranking based on this. Again, I have to go for rank based on this. Again, sorting is required. Isn't it? Sorting based on this points, sorting based on this smallest to largest. Again, I'm supposed to change the rank. That is 1, 2. This has not changed. We have not taken this. Again, no issue, because this has to be same 1, 2, 3, 4 ranking is required. So it hardly matters. Rest other has to change. Sorting smallest to largest. Right. Now here, if you're going to see, so the entire thing is going to change. Are you able to see? Now here, suppose I'm going to take this point. Initially, I'm going to take the value of, suppose, so let me remove all this value. So let's go for some new value, and because somewhere. So I'm going to take new value. At random, suppose I'm going to go for 7th one. So remove this, this. I want to go for the value of K as 7. 7th nearest point I want to go for. In that case, how many C2s are there? So 1, 2, 2 C2, and all are C1. So 2 C2 and rest is C1. 2 C2 and 5 C2. The rest C1. So in this case, again, this majority is of the 5. So it is going to have this 5. That is C2. C2 is going to be. So we are going to take the majority. So this is how the things are really working for you. This KNN algorithm. So any doubt is there up to here? So otherwise we are going to switch to some different algorithm. That is ID3, iterative optimizer. So it's a little bit tough for a student, but you're able to understand very much. So any doubt is there, so let me know. Otherwise we are going to move ahead for second algorithm. But, so
No doubt, sir.
Okay. Now coming back to this very important and little bit difficult from this student point of view. So that is iterative optimizer. So again, the part of your decision tree coming under the supervised learning. So decision tree is also the part of the supervised learning because we are giving that data that is labeled at the same time. If 2 points are there, that is all about your regression and classification, then it is your supervised learning. So we'll take some example of regression also by using Google Colab. So let's see what we can try. So I think that enough time is here. Okay. So after completion of this, we are going to take practical aspect of linear regression or logistic regression by taking some data in Python. Okay, so let's go for this. So this is one of the short example that I took from the university where I was teaching, that is AKT. So it is APJ Abdul Kalam. This university, technical university was there. So in Uttar Pradesh. So I have taken the example. So this was this is a short example that came in 2021. So this was the paper. I mean, copied the test paper of that particular university. So here it is saying that days are defined. Some days are defined, and these are the parameters on which the player is there. So that player is going to play tennis or not depends on some of the parameters. And machine has to learn all these parameters, whether that particular player is going to play, if humidity is there, if temperature is there, if outlook is there, if wind is there. So based on this particular thing, it is going to take some step. Yeah. Okay. And these 14 days are there. So from day 1 to day 14, all the values are being defined over. Now here we are going to learn two things. That is, one is your entropy and another is your information gain. The two important things are there. One is your entropy, another is information gain. So I think it is not useful. Fine. I think it is now, it is useful, isn't it? So this is, first of all, we are going to calculate the entropy, and based on this entropy, we are going to calculate the gain. That is called information gain also. So this chart is given to you. This data is given to you that you in AK2 internship, AK2 exam. So in this, I mean, from day 1 to day 14, 14 days are there. And these are the parameters on which this tennis player is going to play. If they are, I mean, he's going to play, then it is yes. If he is not going to play, then it is no. Yeah. So two categories are defined, yes and no. There is no third one. Fine. Now, what we are going to do, so we are supposed to calculate the entropy. So entropy is nothing but you can say this is some sort of disorderness, isn't it? Say, as for example, in chemistry also we have studied entropy. So entropy of gas is more as compared to solid and so on and so forth, isn't it? And entropy of gas is more than solid. Entropy of gas is more as compared to liquid. Yeah. So entropy is disorderness. So here we are going to calculate the disorderness and the gain factor. If the gain is high, then in that case, that particular gain will be taken care as the root node, and then we are going to descend in order to create that tree. So let's see. So we are supposed to find the entropy of the system. Now, what is the disorderness of the system? Now, system means we are going to take only output, play tennis, isn't it? Now we are going to see how many, I mean, total 14 days are there from day 1 till day 14. Now, 14 data are there. Yeah. This is total 14 days. Now, total number of no. So we are going to see the total number of no. So how many no's are there? 5. 1, 2, 3, 4, 5. 5 no's are there. So 5 negative sign is there. This 5 times this tennis player is not going to play. But out of 14, now 14 minus 5, rest 9 times the tennis player is going to play. Means yes, 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 if you are going to count, but 9 times it is going to say that this yes is there. And based on this yes, one formula is there. That is, here we are going to take minus, negative sign, that is minus the total positive sign. That is how many positive? Positive means yes. So this is positive by total. Total cases 14 days are there. So this is total case. So minus positive by total log base 2. So this is base 2. And the same data, that is positive by total case. Again, after this negation, that is negative minus sign, total negative. So what is negative? 5 in this case. Total negative by total case, log base 2, negative by total case. So this is the formula of entropy. And this is very, very important formula. So by using this, we are able to calculate this 0.94. So we got some data that is 0.94. The entire system, the disorderness of the system is 0.94. Because in most of the cases, it is yes. So that's why it is entropy, the disorderness is not too much in this case. Now, next is we are going to calculate sunny. So we calculated the entropy of the entire system by using this output. Now we are going to calculate the entropy of this output. Then temperature, then humidity, one by one. So first we are going to take for output, because we are able to see that we are taking for outlook right now. So in outlook, we are having 3 different properties. That is sunny, overcast, and your rain. Three different properties are there for this outlook. That prediction is that may be sunny, that may be overcast. Overcast means cloudy. It is still not raining, but it is cloudy. And a cloud is there. And rain. Rain means it is raining. So 3 different aspects we are going to cover. Now this, first of all, we are going to take sunny. So in sunny, now we are going to see how many total sunnies are there in this particular output. So 1, 2, 3, 4, 5. 5 sunnies are there. So total 5 sunnies is there. So out of this 5 sunny, for which sunny it is going to say that tennis player is going to play. So that is positive. That is, it must be sunny, and at the other hand, it is yes. So sunny, no, sunny, no. You have to take sunny, yes, isn't it? Sunny, no, it is not going to work. Sunny, yes. So this parameter is there. So let me make the pointer. So this parameter is going to work for it. Isn't it? That is sunny and yes. So this is one. Here also, sunny and yes. Very good. We are having 2 different values for this sunny. So 2 positives are there. So here we took sunny as 2 positive. Is it okay? Now let's see negative part. So let me erase E. Okay. Now let's go for the negative part. So how many negative? Sunny is there, but negative means that guy is not going to play. So it is sunny and no. So sunny and no. Sunny and no. And this is going to work. So one case, sunny and no. Second case, sunny and no. Third case, and so on and so forth. That's it. So 3 cases are there. 3 cases are there for this negative aspect, in which he is not going to play. So we are going to calculate the entropy in the same way. So how we are going to calculate the entropy? Same formula. Total positive case by participate. Okay. Fine. So negation of negative sign of positive case by total case. So what is the positive case? 2. In which this guy is going to play, even though it is sunny. Even it is sunny, that person is going to play. So 2 by total number of case, log base 2 by total number of case, minus this 3 by 5. So what is this 3? 3 is your negative case. So positive case we have already considered here. Now we are supposed to take negative case. So negative case is nothing but your 3 negative case by total number of case, that is probability, log base 2, 3 number of negative cases by total cases. So it is coming out to be 0.971. So I think it is clear. In the same way, we can calculate overcast. And for this, so overcast, suppose we are going to say positive one. Overcast, yes. One case, overcast, yes. Another case, overcast, yes. Third case, overcast, yes. Fourth case. So 4 number of positive are there. If it is overcast, still that guy is going to play. Yeah, so 4 positive things are there. In the same way, so no negative is there. If it is overcast, and it is known. Is it the case? Nothing is there like that. So it is 0. None of the options are there in this. So let me place. Okay. So in this way, I'm going to calculate all the values for sunny, for overcast, for rain. Isn't it? So for all the values I'm going to calculate, and I'm going to get some value, that is entropy is 0. No disorderness is there in this case. 0 disorderness is there. Here this I got this one. So now the next step is to calculate this gain. So gain of output. So gain of output we are going to consider. The formula is given in this way. So entropy S. So this is the entropy that we already calculated as your 0.94. So entropy of S. So Hannah, here we have written that entropy of S, this one. Okay. So the entropy of S minus sigma of sunny, overcast, and rain. All these 3 parameters, one by one. So this is V. And this V belongs to this one. First time I will be taking sunny. That is here you are able to see. First time I'm going to take sunny. Second, I will be taking overcast. That is overcast. So that's why this sigma is there. I'm going to add all this. And last time I'm going to take the rain. And a 3 parameter variable. So I'm going to take the rain. And then I'm going to add all this. Okay. Now, the formula is saying that entropy this. So entropy this has already been calculated. Entropy of the system, total system. Now, we are going to go for entropy of sunny. What is the formula? SV by S. S is the total cases. How many cases are there? 14 days are there. 14 days are there. 14 cases are there. The total 14 cases are there. Out of that, how many sunny? Because first is sunny. We are going to take sunny. How many sunny? So if you're going to count sunny, that is 1, 2, 3, 4, 5. 5 sunnies are there. So I'm going to put 5. So 5 by 14 entropy of this. So how, we calculated the entropy of sunny. How much? So entropy of sunny has already been calculated. This is that is 0.971. We calculated this. So are you getting? Okay. Assume everything is fine. Clear. Okay. Now coming back to this. Now I think everything is fine. So up to here, I'm going to put all the values. And that entropy of sunny has already been created from here. Entropy of overcast has already been created. That is 0 in this case. I'm going to put the value. So after putting this value, I'm going to get the information gain. So I'm going to get the information gain. Clear? So this is the information gain for outlook. So this is the information gain for outlook. So this is the output of this. Now we are going to calculate for other part of this one. So outlook of this now we calculated. In the same way, we are going to go for temperature. In the same way, we are going to go for humidity and wind. Right? But not for this last one, because this is the output. Right? These are the parameters which is changing the output. Means whether he will play or he will not play based on this given attribute. Fine. So I have calculated the gain for outlook in the same way. This is outlook gain, 0.2, that is 24.64%. So 0.2464 is the gain of your output. In the same way, I'm going to calculate the gain of temperature, gain of humidity, gain of wind in the same way. So I'm just going to show the slides. So this is temperature. I'm going to calculate for temperature the same process. Entropy of the entire system, that is this one, which will be same, 0.94. And then we are going to take, in temperature, we are going to take hot, mild, and cool. See, again, 3 different parameters are there. So for hot, so mild, and cool, for these 3, we are going to calculate entropy. And then information gain will be in this way. That is total entropy, that is 0.94 minus. First time I'm going to take hot, because this is sigma, summation for hot, summation for mild, summation for cool. One by one we are going to take. So this is the total case. This is the total case, and out of the total case, or how many cases are hot? So I think it is 4. So let's see, 4 cases are hot. 1, 2, 3, 4. Getting 4 points are there. Are you able to see that 1, 2, 3, and 4? 4 hot. That's why we have written 4. How many total cases are there? 14 cases are there. Then what is the entropy of S hot? The entropy of S hot is 1. In this way, we are going to put the value and we are going to get the information gain. That information gain is coming out to be 0.0289. That is only 2%. So that is coming to the next slide. So in this way, temperature is calculated. Now we are going to go for humidity. Now we are going to go for wind, so on and so forth. So next we are going to calculate for humidity. In the same way, we are going to calculate the humidity. The information gain is coming out to be 0.15. So we are supposed to look at the information gain which is highest, so that I can put that particular on the very top of the tree, that is root node, and then rest node is going to come into the check. Isn't it? So we are creating the decision tree, which is going to make some decision based on the given input. So this is how we are going to do it. So in the same way, humidity we calculated gain. In the same way for wind also we are going to calculate the gain. Isn't it? So we will go for wind also. So this is the last attribute. So wind, we are going to get some gain. And then we are going to calculate the gain for outlook, temperature, humidity, and wind. And these 4 parameters are there: outlook, temperature, humidity, and wind. What is the gain? The highest gain for this one? So the highest gain is coming out to be this. This is highest among all these attributes, all this column, and all this field. Fine. So this is the next one. So this will be on the top. Outlook will be the root node now. Next, we are going to go for this. So again, the same iteration is going to be repeated. So this iteration was for outlook only, so which will be the root node. Next, this is going to have some children. So based on that, we are going to put the children, and then ultimately, what would be the next node is going to be decided in the same way, exactly in the same way. Okay. So assuming you are getting me. Okay. So this outlook is going to win because the gain is very high. So it must be on the very top that this is going to be the root node. And this is less because 0.2 is less as compared to 0.24, and rest are less. So that's why this will be on the very top root node. So we are able to see that root node is the outlook. And let's see different attributes where they are for this outlook: sunny, overcast, and rain. That will be these are the children for this outlook. And so sunny, overcast, rain is the children of this outlook. And what are the values that that is there in sunny? That is day 1, 1, 2, 8, 9, 11. So let's see. Sunny is your for sunny, for sunny 1, 2, 8, 9, 11. For sunny 1, 2, 8, 9, 11. So for sunny 1, 2, 8, 9, 11. Isn't it? In the same way for overcast, 3, 7, 12, 13. 3, 7, 12, 13 for overcast. Now, just now we have seen in this which will continue. Now, the next step, that what would be the value for this? Which attribute should I take? Whether temperature, whether wind, whether humidity, what attribute will come? That's why it is called iterative dichotomization. So the information is going to be stored iteratively, one after the other. One iteration I did for output, next iteration I will go for this, next iteration I will go for this, and so on and so forth. Right. Now we are going to take this temperature. So this temperature. So you are able to see that outlook is missing because we have already taken this outlook as root node. Clear? And which attribute we are going to take? This temperature. So in this temperature, right now we are going to take temperature. In the same way, we are going to calculate for this particular table. And the table will go on decreasing. The size will go on decreasing. Clear? Why? D1, D2, D8, and that is 1, 2, 8, 9, 11. So 1, 2, 8, 9, 11. See this one? So 1, 2, 8, 9, 11. So the size of the table will be only these number of days. So I think it is okay. Isn't it? Okay. So this is fine. So we are going to have only these number of data to manage. Now, by using this number of data, so why only this data? Because we have seen that in Sunny, only these Sunny data were there. Okay, then we will go for another and so on. So for the time being, we are talking about the Sunny. So in the same way, we are going to go for another aspect. Here also we are going to calculate the gain. Yeah. So next time again, so this is for temperature. This is for temperature. Next time I'm going to go for humidity. Next time I will go for wind. Yeah. So let's go for this humidity. So this is for humidity. I'm going to get some gain. So this is the gain. Again for wind, I'm going to, and last that is this one. I'm going to get some gain with this one. And then I'm going to compare. Yeah. So for Sunny, this was for Sunny. This number of days for Sunny, in which Sunny was found. This number of days, isn't it? So this is for Sunny. Now I'm going to see the attribute, temperature and humidity and wind, which is going to win. What is the maximum gain? The maximum gain is for humidity. Yeah. So just immediate after Sunny, the outlook was there, Sunny was there. So Sunny was there, and just immediate after this Sunny, I'm going to put humidity. Yeah. So this was outlook. So this was outlook, having this Sunny as an attribute, in which just below this Sunny, I'm going to put humidity. So the parent of this particular humidity is going to be outlook. I think getting the point. So let's see. So this is how the things are. Now for Sunny, because humidity information gain was high, so for this Sunny, we are going to take humidity. Then again, this iterative dichotomizer is again we are going to go for iteration for humidity, and now we are going to say this is high, this is normal. How many days are going to be considered in that case high? And how many days are there in which we found high? How many days are there in which we found normal? So in this way, it will continue. So assuming this is fine, we are getting. In this way, we are creating this tree, decision tree, to take some step. So this is at the very top because the gain is very, very high. Okay, so in the same way, this will continue for lot many parameters. So I made this one for temperature. So I'm going to go for temperature. Again, in temperature, we are going to have, in this case, only two values are there, cool and mild. So only for entropy, for cool and mild, we are supposed to take cool and mild. Okay? I think hot is not there in this case. That's why it is not a single hot is there. So in this way, we are going to, in the same way, we are going to calculate the gain, and based on the gain, we are going to take next step. In the same way for humidity, yeah. In the same way for wind also, we are going to calculate. And once I'm going to get all the attributes, I'm going to compare. Yeah. So this is time. So we are able to see that this is time. I can put this, or I can put this. So both are going to be at the same level. I don't have any problem. Oh, sorry. This is the biggest one. So obviously, in that case, I'm going to go for wind. So these two are going to be discarded because the gain is less as compared to this one. So rain will be the next attribute that is going to be attached to this wind. So let's see. So next, here we are going to calculate this rain. So this, for this particular rain, we are going to put this wind. Because wind is going to have higher rates. So in this way, we can create the decision. So I think let's stop over here. All of you are getting this. Can we go for some different algorithm like naive-based? Okay. So I think up to 3:30 we have to continue, isn't it? Okay, let's go for the next algorithm for segregating the data and for categorizing the data. That is your naive-based. Again, one of the important algorithm. So let's go for this. So any doubt is there related to the previous slide? I mean, ID3, iterative dichotomizer. Any doubt is there? One chat is there. So yes means doubt is there or everything is clear. So it should not be all clear. All clear means you're not getting anything. Should not be bouncer. The ball should not go overhead. So I think yes means you are getting. So I hope that. Now coming back to your naive-based. This is also one of the important algorithm for supervised learning. So for categorizing the data and so on. Or should I go for that linear regression first because time is not there? So we should go for linear regression, practical aspect using Google Colab, and then I will come back to this naive-based. Because again, this regression is basically the part of your supervised learning. So under supervised learning, two important things are there. That is labeling, and that is categorization. So category has to be there, classification has to be there, and then next is your this regression. Maybe logistic, it may be your linear. So in logistic, basically it is not linear. So in that case, you might have seen that we have used to take sigmoid function as one of the activation function in neural network. So it is quite similar to that. That is 1 by 1 plus e to the power minus x. So it is going to take that form. Okay. So let's practically go for this linear regression part for logistic. So for that, I need to have, I mean, everybody should have this Gmail account at least to go for Google Colab. I think you did on morning also. So you know how to go for this Google Colab. So here you have to write in Google, you write Colab. Yeah, the very first link, the moment you are going to write Colab, the very first link is your lab.research.google.com. The very important point for this Google Colab is that you're not supposed to bother about the libraries and packages. So all the packages are inbuilt because it is on the cloud itself. So you're not supposed to bother about for pip install and then name of the package. Like this, like pip install matplotlib, pip install numpy, pip install pandas. You're not supposed to go for this. By default, it is there because it is on the cloud, so it is going to take any of the level. So this is your Google Colab, isn't it? So I'm going to go for new notebook, the new one. So I think you got the point. So from Google, I click this link. From Google, I click this link. This link took me somewhere here. That is this sort of window is there. And here I'm going to click new notebook. I'm going to create from the very beginning. So it will look quite similar to your Jupyter notebook. Jupyter notebook here for this Google Colab. So here we are supposed to write the code. So I'm not going to write the code. I'm not going to spoil your time. So I've written all the codes for you. I'm just going to explain that. This there, I'll copy in the notepad. So, this. And I'm going to paste. Otherwise, you have to write coding over here, but it is already there. So without wasting our time, I'm going to use this. So here we are going to go for logistic regression. It may be your linear regression also. So in that case, you are just supposed to put linear word, L-I-N-E-E-R. Instead of logistic, you just put linear, it will be converted. By default, it will be converted into linear. The moment you are going to write this linear means it is linear. Yes. So for the time being, we are using logistic, that is in the form of your 1 by 1 plus e to the power minus x formula. We are utilizing that part. Now here we are importing pandas. So this is name of the variable, isn't it? So panda is one of the packet, and I want to use some of the functions of this panda. So that's why I have written this PD. You may write any variable, A, B, C, X, Y, Z, your name, my name, whatever. And then from sklearn dot linear underscore model. So from this particular package, I just want to take the help of this logistic regression. So is it okay? Fine. So from this particular package, I'm going to take the help of your train underscore test underscore explain. Yeah. So we are going to go for logistic regression, and here we are going to go for training and testing. Two important aspects are there. So I'm going to split the data. I'm going to split the given data into training data and testing data. So am I clear? Now, so here you may take the help of CSV file also. That is very simple one. So in that case, what you have to write, that is pd.read underscore CSV. Within bracket, give the path of the file. So right now I have taken the value here itself. I have taken some data in order to show that how it is really working. So the data is given in this dictionary format. Curly bracket means dictionary. Here we are going to talk about dictionary. One important chapter is there by the name dictionary. So we are using this dictionary in order to take the data. So curly bracket means we are going to go for dictionary. That it is having key value, key and value. So this is key and this is value. Value is given in that list format. Okay. Fine. So this is training and testing. We are going to divide the training and testing data into suppose 80 is to 20 or 75 is to 25, whatever. So training part has to be known. Then only it is going to give the data. And test data will be around 20%, 30%, something like this. In the same range. If it is 80, in that case it is going to be 20. If it is 75, training data is going to be 75. Test data will be 25 in this form. Okay. The total will be 100%. So sometimes the students are committing mistake, what they are doing. So they used to train the data for entire 100%. And then from that 100% data, they will take some data for training and they will show, so I'm getting 100% efficiency. So accuracy is 100%. Sir. So obviously the accuracy will be 100% because the test data on which you are testing, that is the part of your training data. The computer has already understood the data, already fit in that scenario. So obviously, if it has already trained the data points by using that particular data, so if you are picking the data from training data for testing purpose, so obviously it is going to give 100% accuracy. Okay. So that's why we are splitting these two data into 70 to 80 as trained data. Now, next step, we are going to make this into a tabular form. So this GMAT is one of the entrance exam. Okay? This GPA is there. That is quite similar to your CGPA and all that. CGPA out of 5, the student is going to score some CGPA. And work experience, after scoring all this, so he is having some work experience also, 3 years experience, 4 years experience, 5 years experience. So experience is also given. And admitted means whether he got selected in that company or not. So based on this parameter, machine is going to learn. If he scored 780 out of suppose 800 GMAT, then 780, and he's having GP of 4 and work experience of 3. I'm talking about the first parameter. Oh, some problem is there. Just somebody has raised. Let me check. So somebody has raised some queries. So how to see that? So how to see that somebody has raised the point. Yeah, but just check who is there. No, you cannot do that. Not there, but don't get some. Any doubt is there? So write in chat box. So I think somebody raised that, or by mistake it was done. Okay, no problem. So assuming up to here everything is fine. Now coming back to your data frame. So why we are taking this data frame? Because we are framing all this. That is on the very top, GMAT will be there. GMAT is score. On the very top, GPA, GPA column will be there. Just okay. Karthik sir, do you have any problem? You may ask in chat box because we cannot unmute you. Can you write some hint so that I can elaborate that point? Okay, or else we can have some communication later on. So let me go ahead. Okay. Now data frame. So we are dividing the entire thing into a row column format. We are framing this one, isn't it? So the very first parameter is your data. So if it would have been CSV file, like suppose candidate is equal to, suppose we are writing PD dot, that is for Panda, suppose we are instantiating this as your PD. So PD dot, then read underscore CSV, within bracket we are giving the path of the file, CSV file, comma separate file, isn't it? Now here, since we have given the direct value for this one by using this particular curly bracket, that is one of the dictionary format. So I'm going to give the data itself directly over here. And these are the column that is defined for this particular data. That is GMAT will be on the very top, and this will be the value. GPA will be the another attribute, another column, another field, and this will be the value. This all four, 3.9, 3.3, this will be the value. So work experience is going to be on the very top, and these are the work experience for the user. So this is corresponding. So suppose I'm going to talk about 750, means is having 3.9 CGPA. If I'm going to consider second one, that is not the first one. So I'm going to consider second for everybody. This is the way. So second value for work experience. So he got selected. Now based on this, GMAT is scored based on the GPA, and it is going to predict that he got selected. Means he is one of the intelligent person, intelligent student in this field. Okay. So assuming up to here, this line is okay. Fine. Now coming back to your X and Y, two values we are going to take. So Y is one of this dependent variable, and X is your independent variable. So X is having different parameters, GMAT, GPA, that is CGPA or GPA, work experience. Based on this, he is going to get admitted. Suppose he wants to take some admission somewhere in Massachusetts or some different university, which is very highly reputed. So based on this value, we are going to see whether he is going to get admission or he is not going to get admission. So this Y is the output. So output means it is your dependent variable, and X is your independent variable. So based on this X, Y will be decided. Right. Now here this line is very important. So here we are segregating this value. So randomly here, randomly we are going to take 0. So if I'm going to take a random value, so again it is going to arrange itself randomly. It is going to pick the value based on that. Here it is not going to take this value in sequence, and randomly it is going to take some value for training purpose, and then it is going to give the output. Randomly it is going to take some value for this particular data. So it may not be given in sequence. Otherwise, biasing will be there. And every time I'm taking this, and it is going to have bias. Fine. So this X train, so this training data is there, testing data is there, and this is for X. In the same way, Y training and Y test. Fine. So training and testing. So two values from the big data, from this data candidate. Two data is going to be taken care. One is for training data and another is for testing data. Here also you can print the value. You can print the value what computer has taken for training data. So you can print X underscore train. So it will give the training value that X and that particular this computer has considered for training purpose. Fine. So this is for training. Another for testing data, we can check by using printout what are the testing data that the computer has taken. And in the same way, Y means this whether admitted or not admitted. Yeah? So this is Y. So in the same way, for training purpose, so X train, Y train, and X test and Y test. So these two values are going to be taken here. So all these values are going to be copied in this value. And train underscore test split. So this already we have taken from here. Train underscore test split. Now from this package, so it is going to split the data into training and testing. So test underscore size, the size is 75% is given for testing data. And rest 0.25 is taken care for you. This training data. So I think this is your test underscore size. So I'm going to decrease it to 0.25. And you can give both the parameters also simultaneously. Test underscore size and train underscore size. Both are correct. But if you're going to give only one, it is going to take the other one. By default, it is going to take the other one. Otherwise, also you can give train, TRAIN underscore size is equal to 0.75 in this way. So that is good. Now, next is, I'm going to take another variable that is by REG, regression REG, logistic regression. For linear regression, we are just writing linear, LINER, linear is going to work. And then we are going to use fit function. So why we are using fit function? Because it has to give the minimum error. Suppose I'm going to create one line and based on this scattered data. So which line is the best line for? So that the root mean square error is minimum. So let me show that. So basically I'm talking about this part. So these are the scattered points, and from here to here, we are calculating the errors. Clear? That is root mean square error we are calculating, and it has to be minimum, isn't it? So it has to be minimum. I mean to say, why I am not taking this line? Why I am not taking this line? Why I am not taking this line? Because error of this line is much higher as compared to this one, as compared to this one. Because if you are going to calculate the distance, that is perpendicular distance of this line, that is shortest distance, perpendicular distance. So it will be very high. That's why we are not taking this line. Yeah. So we are taking only this line. So we are discarding this line. Because error is very high as compared to the error. So we are supposed to take the line which is going to give minimum error. So I think we are getting it. So that's why I have taken this one. And ultimately I'm going to predict the value of this one, printing the predicted value of this, that is 0, 1, 0, whatever may be the prediction. And what is the accuracy of my model? And 80%, 20%, 30%, whatever may be the accuracy. But it all depends on the data that you are filling. If randomly you are giving the data, you may not be getting the accuracy. Like randomly I have given some value. So if GMAT score is very high, GPA is very high, work experience is very high, but still I am going to give 0. So it is not going to work. If all the parameters high, that means he must be admitted. So if this sort of data is going to be taken, you may not be getting accuracy nearby 98, 99%. And you will be getting accuracy depending on the data that you are choosing. So data has to be very accurate. That is very important. So let's try to run that. So for running, we are going to click this button, run button. So here you are able to see it is allocating some server. It is going to give RAM for me. It is going to give some hard disk space for me because we are working on your cloud. So it is free of cost. We are not paying anything for that cloud. From Google, it is free of cost. So we are able to see that it is connected and it has given some RAM somewhere from some machine and assign some disk for hard disk for me. That is free of cost. Okay, so this part is okay. Now we are going to predict. So here, this is the prediction. So this is the prediction. That is the test data that we have predicted. These were the test data, and this is the accuracy. So this is good accuracy, assuming that the data are. But right now, I mean, even for 80% is not enough. So out of 100 data, it is going to say correct. It is going to give correct output for 80 data. Out of 100 data, 20 data it is not going to give the correct answer. So the prediction will be only for 80. So out of 100 test data, it is going to predict accurately, correctly for this 80 data. So from confusion matrix also you can make you can see the output. So accuracy means that is 2 positive plus 2 negative by total number of cases, isn't it? So if it is correct, suppose if I'm COVID positive, system must say I'm COVID positive. If I'm COVID negative, system must say I'm COVID negative. Then only this is the favorable case by total number of cases. That is your accuracy. And this accuracy is nothing but your harmonic mean of your recall and precision. Fine. Again, precision is having its own formula. So precision is having 2 positive by 2 positive plus false positive. And the reverse of this one is your recall. That is 2 positive by 2 positive plus this false negative. So based on this, we are going to have this accuracy. And then ultimately we are going to get some sort of F1 score, that is harmonic mean of your precision and recall. So it is F1 or F score. Why it is F1? Because maximum value I can get is 1. Because in probability form, 1 means 100%. So you may write F or F1, both are same. Fine. So this is all about from my side. If any doubt is there, so I'm going to take the doubt from your side. Hope my voice was clear. So you may ask something that is there in your mind. Or you may put in chat box. Yeah. So otherwise also you can contact me, those who are here in this campus. If you want to have some query, you may ask the query. So otherwise we are going to wind up here. So tomorrow I will be taking that K-mean clustering, and that is all about your unsupervised learning. So that link will be given, provided to you, also some chat things. Also, somebody was saying things. So, okay, thank you, sir. Thanks a lot. Session was very informative. Thank you, sir. Next session. Thank you, sir. Thanks a lot. Some more topic were left, like naive base and all that. So not many algorithms are there. So since because of lack of time, we cannot continue. Maybe on some other day we are going to continue the left out part of your ML. So hope everything is damn clear. Thanks, sir. Thanks a lot. It was good. Thank you, sir. Thanks, sir. Thanks.
Thank you, sir, for this amazing session on machine learning. The real-time examples you shared were helpful in understanding the concepts better. Thank you, sir. Thank you all for attending today's session. I hope you will join the further sessions. Our tomorrow's session will start from 9:30 a.m. Please join the same link on time. Thank you.
Thanks, everybody. Thanks a lot.
So thank you, sir. Thank you, sir. Ajay, sir.
Thank you. Thanks a lot, sir.
Thank you. It was a very interesting session indeed.
Fine,
Thank you,
fine. Thank you. Thank you very much, sir.
Yeah, dear participants, feedback link will be shared through the WhatsApp group now, immediately after the session. So tomorrow morning we have 9:30. The session is machine learning based recommendation system for e-commerce, streaming services, and healthcare. And followed by we have hands-on use cases using Python at 11 o'clock. So there are two sessions in the morning. You can join the session using the same link. Thank you. Thank you, everyone.
Thank you, sir. Thank you, Mahesh. Okay.